Okay, all right, here we go. Okay, hey everybody. We're gonna do a quick YouTube stream here for these here functions. Give me a second. I've got to share the link with my team so they can see this in real time. Those of you watching this later on in the future, fast forward a little bit until you see a little bit of writing on the screen. What I'll do is if I ever have to talk or set stuff up at the start of a video, I'll put like start here on the screen so you can just fast forward with your finger. You know what I'm saying? That way you don't have to like try to figure out like where it lasted, okay? Because I know how that is. Like many of you will just need to skip straight to where we start. Like I know we haven't started yet, but work with me here. I'm trying. All right, so give me a second, get them set up. Remember, you can just fast forward to where you see my writing on the screen, okay? In the meantime, this video will be about functions. It's going to be brief. You're going to need to pause a lot during my videos, okay? I try to set them up to where I explain it to you really well, but I'm going to go super fast. It's your job to pause it where you need and then work the problems. Do not watch this whole video. Pause the video and work problems. That is the key to your success in math. All right, here we go. So we're gonna begin here. All right, begin here. Okay, this is so all of you can see like where we're actually starting the lesson. All right, so this lesson is about functions, okay? When we talk about functions, you're gonna hear the words input and output, but I don't want you to worry about that so much right now, okay? Don't worry about that so much right now. The key thing I want you to take away is when something happens, something else happens. So for example, when you light a fire, that fire could turn into a blaze. If you turn a switch, that switch could turn the lights on. Now I know I could turn it off also, but just work with me here. When you do something, something else happens. When you do something, something else happens. What you do is the input. It's literally you putting in. What happens because of what you did is called the output. It's literally what is put out from what you put in. Okay? If that sounds like, what does this have to do with math? Rewind it back to that later. All right? Let's get on with what's going on in these problems. Oftentimes with inputs and outputs, you're going to see graphs. So let's pretend this is 1, 2, 3. 1, 2, 3. All right? Now, this is going to require you to remember a decent bit from 7th grade, but let's just stay with it for now. In fact, let's come back to this in a second. I want to take you backwards into 7th grade for a second because this may actually be more helpful than just starting in the middle of functions, okay? Remember that in 7th grade we talked about like y equals something. So y equals like 2x or y equals like x plus 3. It doesn't matter. And as long as you know what x is, you can tell what these are. So if x equals 10, what is y? Pause it and give it a shot. Okay, I'm going to go ahead and give you the answer. In this case, y would equal 2 times 10. Therefore, y equals 20. Okay? In this case over here, y would equal 10 plus 3, which is y equals 13. Notice that in both cases, you simply took what x is and literally stick it where you see x. Because if x equals 10, then you can put 10 anywhere x is. In this case, it's next to the 2, and in this case, it's next to a plus 3. Some of you may struggle with, why is this times here? Remember that in math, anytime you see two things sitting next to each other, so 5x, AB, 5 times 3, doesn't matter. When you see two things randomly sitting next to each other, that means times. That means multiply. So this literally reads 5 times x. This literally reads A times B. This literally reads 5 times 3. Okay? So in this case, let's get rid of some of this. In this case, 2 times x, which means 2 times 10, which is how we got to 20. In this case, they're not sitting next to each other. There is an x followed by a plus 3. So that literally means 10 plus 3 because x is 10. That's how we got that part so far. Okay, if you're not sure, just rewind it and have a look at it. Let me give you 2 to practice on before we move on to what this has to do with functions. But you have to really have this down to understand what's going on with functions. Here's 2 more for you to try on your own, and I'll write the answers for them shortly after, so make sure you work it on your own, okay? Pause here. I'm going to give the answers immediately afterwards. All right, here are the answers. Oh, sorry. I did not give you x equals. Y'all, my bad. There you go. Now pause here. All right, and then if you need to, if you're stuck on this part, if you're not stuck on this part, just keep watching. All right, great. Pause here if you haven't. Okay, here come the answers. So y equals 5 times 12, which is 60. And y equals 12 divided by 3 plus 5. 12 divided by 3 is 4. Y equals 9. Okay? All right, we're moving on. So what's this have to do with functions? Notice that in this example, y equals x plus 3, that if x equals 10, there is only one possible answer for this thing, 13. In this example here, this example can only have one answer if x is 10. Because if x is 10, then 10 plus 3 is 13. If I say x is 10, there's no way for me to get 15 for this. I can't get, here, let me rewrite it underneath here for you. Y equals x plus 3. So y equals 10 plus 3, which is 13. There's no way for me to get 15 here or 20 here without changing this or this. For this one formula, I can only put in, if I put in 10 for x, I can only get one answer. Now, if I change x, I'll get a different answer. Y will equal 14, and that's okay. If I change x, I will get a different answer. Remember that x is, remember we talked about inputs earlier. So if I change what I put in, I will get a different output, and that is okay, that is normal. This is a function. A function is anything where you put in an input and you get one output, meaning you put an x in and you get the same answer out, or you get the same y, or you get the same output. If I gave you this and I said x equals 5, and you told me the answer is 20, and the answer is 30, that makes no sense. That is not a function, okay? You're not getting two answers from that. X cannot be 5, and this thing be y equals x plus 15. and you get 20 and 30. You'll get 20 because 5 plus 15 is 20. Or sorry, yeah, 5 plus 15 is 20. You'll get 20, but there's no way for you to get 5 plus 15 equals 30. Not without changing the problem. Remember, this assumes you don't change the problem. If you keep the problem the exact same, you should get one answer out for the same input. Or, in this case, you should get 1y for every 1x that you put in. Remember, this is the in, this is the out. This is what you put in, this is what the answer is. These all mean the same things. Output equals answer. Input equals what you put in. Input equals x. Output equals y. Answer equals y. You can call it whatever you want. It's all the same stuff for the most part, okay? For our purposes, at least in middle school. Got it? It should still feel hazy if you're actually starting to get it. So if you don't get it yet, that's okay. That's normal. But you shouldn't feel completely lost. If you feel completely lost, rewind. But if you feel kind of hazy, that's normal. All right. So fine. Y, let's say this. Y equals x squared. Okay? And I say x equals 5. All right? Let's put that in. Y equals x squared, so y equals 5 squared. And hopefully you remember from 7th grade that this little 2 means to multiply it times itself. If it doesn't, that's what it means. So 5 squared is 5 times 5, and that is 25. So we're saying when x equals 5, y equals 25 for this. You put in 1x, and you got 1y. This is a function. Trick! What if I said, for this exact same one, let's change colors to make it easier to see. Y equals x squared, so it's the same function, but let's change the number. X equals negative 5. Okay? Let's zoom out some because you're going to need to see both of these. Y equals negative 5 squared. And negative 5 squared is the same thing as negative 5 times negative 5. Which is, and y'all can put this in calculator if you need to, 25. Well, look here. We got the same answer for both. So y equals 25 and x equals negative 5. But notice, this is still a function, and here is y. No pun intended. You used a different input. You used a different x. We used negative 5 over here, and we used positive 5 over here. The x's are different. Even though their answers are the same, the x's are different. So even though the answer, the y, is the same, the x's are different. Okay? That is allowed. These are both functions. Because you changed the x. And when you changed the x, even though you got the same answer, it's still a different x. It is not a function if you have the same x, give two different answers. That's not happening. Okay? That's not happening. That is not a function. All right? Take a look at this set of numbers then, and tell me which ones you think are a function. If x equals 1, y equals 10, x equals 1, y equals negative 10. X equals 1, y equals 5, x equals negative 1, y equals 5. X equals 1, y equals 6, x equals negative 1, y equals 6. X equals 1, y equals 10, x equals 1, y equals 11, x equals 1, y equals 10, x equals 1, y equals 10. Pause. Give it a shot. Tell me, here's what you're going to do. Tell me if it's a function or not. Pause, give that a shot. Okay, if you haven't paused yet, I'm getting ready to give the answer. All right, here we go. Okay, so on this first one, I've got x equals 1, and that's 10. The only time, so the only number I should see next to a 1, in this case now, is a 10. I can't have x equals 1 and some other different answer. That's not a thing. It's not a function if I get that. So x equals 1 and y equals negative 10. Okay, that's not possible. This is not a function. Nah. Okay? X equals 1, y equals 5. These are locked. You can think of it like that too. Once you see what that x is, think about the x being locked to a single answer out if it's a function. So I better not see a regular 1 next to any other y. Otherwise, it's not a function. This says x equals negative 1. Well, negative 1 is not the same thing as 1, so it can be anything it wants to be. Y equals 5. Okay, that's fine. Because even though they got the same answer, these are two different x's. So I'm okay with this. Yes, this is a function. Because I have x equals 1, and it has an answer, and then I changed the x. So I can get the same answer, that's fine. Or I can get something different, that's fine too. But every x has got to have a different, here, let me reword it. Once you have that x equals something, it's locked. It can't change answers. Go on to number 3 with that thought process. X equals 1. So this 1 is locked to whatever I see next. Y equals 6. Okay, fine. This 1 is locked to 6. So I can't see this 1 next to anything else. Alright? X equals negative 1. This is different. So this can be the same thing. Y equals 6. This is still a function. Because the x is different. The x is the one that can only be locked to one other y. Okay? X equals 1. So I'm going to lock this to 10. I can't see x equals 1 next to some other number. X equals 1, y equals 11. That's not happening. That's not a function. Okay? X equals 1. So now this is locked to 10. I better not see it next to anything else. X equals 1, y equals 10. This is a function. In fact, those are the same thing. There is no difference between these two. There's no difference. So that's not a different problem. Okay? All right, let's move on to the next. Another funny way that may help you remember which one is which, because many of you get it confused when you think, is it X that has to have a different answer, or is it Y? A lot of people get this crisscross, especially creative people, because our brains tend to intermix things. Here's a funny way you can remember it. Is think about X as in the term X, as in someone's ex. And think about a jealous ex not thinking about, like the jealous ex doesn't want to see you with anybody else. So think about it like this. If x equals 2 and it's next to y equals 5, it had better not see that 2 with anybody else. So if it says x equals 2 and it sees y equals 10, not a function. It's very upset x, okay? That may help you remember that it is the x that you're looking at that has to be with a different answer. And that the y, you can have the same y as long as it's for two different x's. But the same x does not want to see you with different people. The x wants to see you with one person and one person only. Now, I know that's funny, I know it's even somewhat crude, but it'll stick in your head, and that's the stuff you need for tests. You need stuff that will stick in your head with little to no effort, okay? So let's try a couple of practice problems again, this time with that knowledge. The same x can only be with one answer. I'm going to give it to you in a chart form this time. 5, 3, 5, -5. Is this a function or nah? Hopefully, you are saying nah. You have the same x with two different people. Upset x. Okay? Not a function. How about 2, -2, 3, and 3? Is this a function? Hopefully said, yes it is. You know why? You have two different x's. And even though they're with the same number, it's two different x's. There's no jealous x's here. So yes, this is a function. Congratulations. Ding! Okay, good. How about this one? Is this a function? Yes or no? Okay. Hopefully you are saying a no, because you see the jealous x with two different numbers. Nah, there's a jealous x present. It's not happening. Not a function. Okay? All right. Here's another one. Function or nah? Do you see any jealous x's? And when I say jealous x's, I mean, do you see the same x with two different people? Two different numbers. All right? Hopefully you saw this and said, oh my God, there's a jealous x down here. That is not a function. And that is correct. This is not a function because of this bad boy down here. Okay? Great job. Now you try these on your own. I'm going to give you a few to try on your own. And then we're going to be wrapped up here in the next 5 minutes. So here's some you can try on your own. I'll give the answer shortly after, so make sure you pause me. Okay, pause me here. Okay. Given the answers, here we go. All right, so far, let's have a look at this. I see none of the x's are the same. This is a function. None of the x's are the same. We're good. Okay, I see two x's that are the same with two different answers. Two different y's, two different outputs. This is not a function. We have a jealous x. We have a jealous x. It's right here. That's not a function. Okay? These x's are different. Even though the answers are all the same, the x's are different. And because of that, this is a function. Remember, we're looking for jealous x's when we talk about is something a function or not, okay? We're looking for the same x with completely different y's. The same x with completely different dates. That'll stick in your head, all right? Now what we're really looking for, let's get mathematical for a second. What we're really looking for is, does the same input make a different output? Because if so, it's not a function. It's not something predictable. It's not something... We're going to leave it at that. It's not a function, all right? For it to be a function, you need the same input to give the same output. Or, if that starts confusing you, that's all mathematical jargon for, or really abstract jargon, for the same jealous x's. The same x should be with different y's. And if you see that same x, with different y's, it's not a function. If you see different x's with the same y, it's fine. If you see different x's with different y's, it's fine. You just cannot see the same x with different y's. Rewind this video if that's unclear. Here's some bonus problems here for you. We will do a, I will give you another video on this later on. But here's some bonus problems. Or here, I'm gonna show you. Actually, I'll give you some bonus problems in a second. Here, let me show you one more way to look at this, because I was like, should I wrap it up there? I kind of tempted, but not really. It leaves out one important way to see this, which is through graphs. And I promise you we would come back to this too later anyhow. All right, in order to read graphs, it's the same thing. Nothing's changed, okay? We're looking for jealous x's. There should be no same x's with two different answers, two different y's, okay? Different x's can go with different y's, but the same x cannot be with different y's, okay? This is about what's happening with the x. All right, so fine. Remember that this is the x-axis here, and this is the y-axis. All right. Let's say I've got a dot here, a dot here, and a dot here. All right? Take a look. This, and let's label this. This right here, these are all different x's, okay? And they all only have one dot each. This is a function. Pretty important to put that in there, but I didn't spell a cuss word because I was missing a letter, all right? I missed a letter. This is a function, okay? This is, because each x only has one dot. It only has one y. Now that y happens to be the same for all of them. The y in this case for all of them is 1. Okay, if you were to write this out, this would look like this. Ta-da! But notice, different x's, same y, but it's still different x's. Remember, we're looking for the jealous x, so there should only be one dot per y. So what would it look like if it were a jealous x? I'm going to zoom out so you can have another example that's right next to it. Let's put a dot here, and a dot here. Well, ladies and gentlemen, have a look at that. What do you notice? We've got the same x with 1, 2, 3 different y's. Oh my god. Okay? Look at this. 1, 1, 1, 2, 1, 3. That's this right here. Then we got 2, 1, and 3, 1. Well, shoot. These guys over here are okay, but this is not. And remember, the function is the whole graph, not just the individual dots. If any of the dots have an x that repeats itself with more than one y, it is not a function. Ladies and gentlemen, we have a jealous x. Okay. Okay? Now you try a couple. I'm going to give you a mix, and then I'll give you the answer shortly after, and then we're going to be wrapped up for today. here is some problems, which I'm just going to call some opportunities. All I want to know is function or nah. This right here means function. I want you to get used to looking at it like that. When I hear the word function, this is literally what I see in my head, f of x. I don't even see the word function. I see f of x in my head, okay? You'll get like that too with enough math. All right, here we go. Bloom, 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 okay? And then, let me see if I can cheat a little bit here. All right. Let's do bloom, 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 bloom. Okay. And then let's do oh man, too good. Telling you. This is called working smarter, people. Don't work harder. All right. Let's do bloom, 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 bloom. Okay. And then let's do bloom, 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 bloom. Okay? Work through those. Pause me if you haven't already. Remember, you're looking for jealous x's. Every x should only have one y to it. The other way to think about it is every x should only have one dot above it. And if it's got more than one dot, that's an issue. That's a no-no. Okay? Pause me now. If you haven't already, I'm getting ready to give answers. 3, 2, 1. Here they are. All right. I see an X with more than one dot on it. This is, let's put the coordinates for this. This is 1, 1. This is 2, 1, 2, 2, and 2, 3. That is a problem. You've got one X with all of these Y's. That's not happening. I see jealous X's. That's not a function. Okay, great. All right, let's look over here. I see 1X with 1Y, 1X with 1Y. I see 1X with 1Y, 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 1X with 1Y. And let's just make sure this is right. This over here is -4, 1. This is -3, 3. This is -2, 1. This is -1, 1. This is 1, 1, 2, 1, 3, 1, 4, 1. And although they all have 1 in common, they're all different x's. This is okay. This is a function. Each x only has one y. Okay, this one's got 1. This one's got 1. This one's got 1. This is just 1. Okay, 0, 0 is fine. It's just 1x with 1 y, no problem. Here's 1, here's 1, here's 1, and here's 1. So each x only has 1 y. Each input only has 1 output, no problem. This is a function, no jealous x's. Okay? Let's check this one. I see 1x, 1y, 1x, 1y. There's no dot here. 1x, 1y, 1x, 1y, because the x here is 0. This is 0, 3 right here. 1x, 1y, 1x, 2 y's. Uh-oh! This is 2, 1, and 2, -1. I see the same x with 2 different y's. You cheating! Jealous x! Jealous x is out here. This is not a function. Get it out of here. And you know, when you work these, the minute you spot the same x with 2 different y's, you can just immediately write it off as not a function. You don't have to keep working. It's not a function. All right? Good stuff. Some of you may have heard something called the vertical line test. And that's another way you can tell if something is a function or not. Now, what it really does is it just helps you put a drawing to what we've already talked about, which is if you see an x with more than one y, in this case, this is 1, 1, 2, 1, 3, 1. So all these different x's with the same y, yeah, that's not happening. It would fail something called the vertical line test, which means if you draw a straight up and down line through a function, if it hits more than one point, it's not a function. So this is not a function. Okay? I don't like to spend a lot of time with the vertical line test, though, because it doesn't tell you what you're really looking for. And if you already know that you can only have one x, or sorry, you can only have one y for every x, then you're okay. So just I recommend you just look and just make sure each x only has one y and that it doesn't have two of them, because that is a big no-no if it does. Okay, it should only have one. So in this case, if I scratch these out, now this would be a function. Ding! But since it's got all those dots, this is not a function because we have jealous x's. Okay? All right, here's a few you can work on your own. I'll give you some these are your practice problems. Work them if you need to. If not, you can skip this if you feel good about it already. But here's some you can work on your own just to feel extra super confident. Remember, the moment you spot the same x with two different answers, it's already not a function. Just move on with your life. And so at this point, if you're really grasping what's going on, you should be able to basically just eyeball these, and the minute you see that pattern, it's over. Okay, I'm gonna give you the answers to these in 5, 4, pause me, 3, 2, 1. All right, I see the same x with two different y's. This is not a function. I'm not even gonna like move on into it. Not a function. I see different x's. All right, cool. It doesn't matter if they're the same, if they have the same answers. I see different x's everywhere. This could be a function. My brain is going so fast. I gotta watch my spelling here. All right. I see different x's, and even though they all have the same y, that doesn't matter. I see different x's. For that reason, this could be a function. I see different x's. It doesn't even matter if they're the same y. I see different x's. So this could be a function. I see different x's. Doesn't even matter that they have the same y. I see different x's. Therefore, this could be a function. Done. Just like that. Try it with these. All right, pause me. Okay, here come the answers. All right, here we go. I see two of the same x's. They had better have the same answer. They do not. This is not a function. Jealous x's. Okay. These are all the same x, or sorry, these are all different x's. It doesn't even matter that they have the same y's. That doesn't matter. They're different x's. There's no problems here. Not a function. Or sorry, this is a function. Sorry. It's a function. You have different x's, okay? You don't have any of the same x's with different answers. All right? These are all... Okay, I see the same x's here. Do they have different answers? I see 2, 1, that's good to go. I see 2, 1, that's good to go. Mike, why is that good to go? Because these produce the same answer. 2, 5, this produced a different answer. The same x with a different answer. That is a problem. That is a problem. Jealous x's because I have the same x with a different y. Not a function. All right? Last pair of practice problems I'm giving you. I know I said it was last pair like 5 times, but practice makes perfect with math. That is why I named our passes for you to come tutor with us, or practice with us, as practice, because that's really all learning really is practicing. Well, wait, I take that back. But that is a core engine behind learning, is practicing. Okay, what you do with the practice is very important to learning. But it all happens with practice. All right, try these. I know it's poorly drawn, but hopefully at this point it doesn't even have to be good drawn for you to see what's going on. Okay, pause me now if you haven't already. Incoming answers, incoming answers, incoming answers, incoming answers. Okay. All right, here we go. All right, I see the same x with 1 y, but I see the same x with 2 y's here. Jealous x's, not a function. Not happening, people. Okay? I see 1x, 1y, 1x, 1y, 1x, 1y, 1x, 1y. Good to go! This is a function. I see 1x, 1, 2, 3 y's. Are you kidding me? Are you kidding me? Jealous x's, people. Not a function. Alright, great. Don't know what I just wrote. Alright, here we go. I see 1x, 1y, 1x, 1y, 1x, 1y. Okay. Ding ding. This is good to go. This is a function. I can rock with this. I can rock with this. Great job. Ding ding. This is a function. All right. Hopefully that helped. One last thing. This is not a practice problem. This is just me showing you something. With the vertical line test, you can use it to see if 2 points. Now look, remember I told y'all we're looking for jealous x's. If it helps, you can, let's say you have a graph that looks like this. You can look to see if the same x is hitting this graph at a different point. On this graph, it's not. Like here's an x, here's a y for it, here's an x, here's a y for it. Like they're all different. But if you compare that to something like this, let's zoom out so you can see both. This could not be a function, and here's why. Here's an x, but the y would be here, 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 and here. Because that is straight up and down from that x. Can you see that? The x here, if you go straight up and down from it, it hits the graph at 1, 2, 3, 4 different places. So this is not a function. This would produce jealous x's, because you have the same x hitting the graph at more than one place. Not a function. Jealous x's. We're not having that. No. Not a function. Okay. Do not spam that phone number. I'm about to cut that. Okay. Anywho, alrighty. See y'all later. Best of luck. Keep killing the game. And yeah, that's all I got for you. Cause I didn't expect the phone number just like pop up like that. I'm gonna have to edit that part out. If you're hearing me right now, then I've already clipped the part out. So we're good to go. Because I don't want nobody's phone number on blast. Y'all be spamming, folks. I heard. Because I remember I did a stream last year and somebody called. And then they told me later like people were hitting their phone. So y'all ain't getting none of that. Alright, anywho. Alright, hopefully that helps. We'll visit this again later. I got to go. Alright, peace out. Have a good night.